Yesterday I gave you an equation that described the force of gravity between any two objects with mass. That equation looked like this. F stands for that force of gravity. That force of gravitational attraction, it's going to be measured in newtons always. M1 and M2 are the two masses involved. Doesn't matter what order you list these in, just make sure they're measured in kilograms. R stands for the separation distance, the distance that separates the two masses. Some people get this confused with a radius. It's not necessarily a radius. It's just the distance between the two objects where you're trying to find the force of gravity. That's going to be measured in meters. And G is called the gravitational constant. That's not 9.81. Rather, that's 6.67 times 10 to the negative 11 Newton meter squared per kilogram squared. If you forget that number's on your data sheet. You can just check the back of your data sheet to get that for your quiz, for your test, or for your worksheet that you're going to work on in a few minutes. Today what we're going to do is use this equation to answer some questions, starting with example number 1 on your handout. Example number 1 says a 100 kilogram mass is separated from a 200 kilogram mass by 2 meters. We want to find the force of gravity that the 100 kilogram mass exerts on the 200, and then the force of gravity that the 200 exerts on the 100. We're going to say that our mass 1 is 100 kilograms, and we're going to say that mass 2 is 200 kilograms. We're going to say that the value of r, the distance that separates them, is 2.00 meters, and we're looking for the force of gravity. We're looking for 2 forces of gravity. We'll just worry about 1 right now, solve for the other one after we're done this one. Now the equation that we're going to use to solve for this force of gravity is gm1 m2 over r squared. That's going to be 6.67 times 10 to the negative 11 times mass 1, which is 100 kilograms, times mass 2, which is 200 kilograms. By the way, I could have reversed those and made it 200 times 100, would have given me the exact same answer. R, the distance that separates them, 2.00 meters. Now we're going to square that. Let's pull out the calculator to determine what the value of this is. We're going to say 6.67 times 10 to the negative 11 times 100 times 200. We're going to divide that by 2.0 meters squared. We get a value here for the force of gravity of 3.34 times 10 to the negative 7 meters. That's one force. What's with the other one? Well, you know that if object A applies a force on object B applies an equal and opposite force on object A. So I found the force of object A acting on object B, but I've also found the force of object B acting on object A. So both of these questions, A and B, end up giving me the exact same answer, 3.34 times 10 to the negative 7. Just the same. Remember Newton's third law. For every action, there's an equal and opposite reaction. Let's take a look at example number 2 now. Example 2 says, find the force of gravity that acts between the Earth and the Moon. Now, it looks like we're missing some data here. If we check our data sheet, though, we're going to find that the mass of the Earth is 5.97 times 10 to the 24 kilograms. Look at the back of your data sheet and you'll find that number. Same place, you'll find the mass of the Moon. It's going to be 7.36 times 10 to the 22 kilograms, about 100 times lighter than the mass of the Earth. Now, you're also given a distance between the Earth and the Moon on the back of your data sheet. It says the average Earth-Moon distance is 3.85 times 10 to the 8 meters. Now, that distance that you're given represents the distance from the center of the Earth to the center of the Moon. And that's exactly what distance you want. You don't want it from surface to surface. You want it from center to center. And again, that's the distance that you have given to you on your data sheet. We're going to use our equation again to find that force of gravity that acts between the Earth and the Moon. Gm1 m2 over r squared. G is 6.67 times 10 to the negative 11. That's the universal constant. Times m1, we're going to make it 5.97 times 10 to the 24. Times m2, which is 7.36 times 10 to the 22 kilograms. And we're going to divide that by r squared. 3.85 times 10 to the 8. Don't forget to square that. Now let's pull the calculator for this one. This one's a little bit tougher to do on the calculator. Let's say 6.67 times 10 to the negative 11 times 5.97 times 10 to the 24 times 7.36 times 10 to the 22. Now let's divide that by 3.85 times 10 to the 8 and make sure we square that. We get a value here of 1.98 times 10 to the 20 newtons. That's a really big force. Why is it such a big force? Well, if the moon is to stay in orbit around the Earth, the moon is pretty heavy, so it requires a pretty big force. I'd like you to pause the podcast right now and have a look at your worksheet now, specifically worksheet number 22, questions 1 to 8. Once you're finished questions 1 to 8 on worksheet number 22, then you can start up the podcast again and do example number 3. If you've completed questions 1 to 8 on worksheet number 22, then have a look at example number 3 now. This one says a 50 kilogram mass is separated by a second mass by 1 meter. The force of gravity acting between the two masses is 2 times 10 to the negative 7 newtons. What's the value of the second mass? I'm going to say that M1 is 50 kilograms. I'm going to say that R, the distance that separates them, is 1.00 meters. And I'm going to say that the force of gravity that acts between the two masses is 2.0 times 10 to the negative 7 newtons. I want to find the value of M2. Same equation applies here, but I'm going to have to do some algebra and rearranging. I get F is equal to GM1 M2 over R squared. Solve for M2 means I got to take the R squared up by multiplying first. F times R squared is equal to GM1 M2. Solving for M2, I've got to take G and M1 over by dividing. Gives me a value of, or an equation of F times R squared divided by G times M1. Let's sub our numbers in for this now. We get 2 times 10 to the negative 7 for force. R is 1.0. We get a bit of a break here because when we square 1, we just get 1. G is 6.67 times 10 to the negative 11 times M1, which is 50 kilograms. Let's pull up the calculator again for this one. Let's say 2 times 10 to the negative 7 times 1 squared. Let's divide that by, make sure you use some brackets on the bottom here. Multiply the 6.67 times 50 inside the brackets. When we do this, we get a value of 59.97 newtons rounded to 2 significant figures. That's going to give me 60 newtons. Second mass is 60 newtons. That seems reasonable given that we had a first mass of 50 kilograms. Sorry, that should be 60 kilograms rather than 60 newtons. And once you've kind of got the gist of example number 3, I'd like you to pause the podcast again. Take a look at worksheet number 22. Specifically this time, I'd like you to look at questions 9 to 11. Once you're finished questions 9 to 11, I'll ask you to come back to the podcast and take a look at example number 4. If you've finished questions 9 to 11 on your worksheet, take a look at example number 4 now. Example number 4 says 2 1 kilogram masses exert a force of gravity of 2 times 10 to the negative 3 newtons on each other. Determine the distance that separates the two masses. We're going to say that M1 is 1.0 kilograms, so is M2. There's a force of gravity that acts between these two objects of 2.00 times 10 to the negative 3 newtons. We're going to solve for the value of R, the distance that separates them. The equation is the same. Once again, we have to do some algebra, this time solving for a different variable, R. GM1 M2 over R squared. Now, R squared is on the bottom. It's got to go to the top first. I get F times R squared is equal to GM1 M2. Let's get rid of the F now. It's multiplied by R squared, so let's get rid of it by dividing. R squared is equal to GM1 M2 over F. And now let's square root that in order to get the value of R. So square root of GM1 M2 over F. Now, let's sub some numbers in for this. We're going to say G is 6.67 times 10 to the negative 11, as always. M1 is 1 kilogram, so is M2. Divided that by the force of gravity that acts between the two objects, 2.00 times 10 negative 13 newtons. Let's square root that. And now let's do the math. Let's say 6.67 times 10 to the negative 11, times it by 1, times it by 1 again. Let's divide that by 2 times 10 to the negative 3. Let's square root that. And when we do, we get a value of 1.8 times 10 to the negative 4 meters. Once you've got the gist of example number 4, I'll ask you to, once again, take a look at worksheet number 22. This time I'm going to ask you to finish off the worksheet, which is questions 12 through 14. That's your assignment for today. Please make sure that you understand all 4 of these example questions and that you can do all 14 of the questions on worksheet number 22.